All right, guys, recording this video here to talk about then the second part. So what I've done already is I've done a little bit of research into these three materials, A992, A36 steel, and 6061 aluminum, and I found their yield strength. Important thing to notice, yield strength. We don't want the ultimate tensile strength. Ultimate tensile strength is when it will fracture. Yield strength is when it will stop acting elastically, and that's what we're more curious about. So make sure we're finding the yield strength, not the ultimate tensile strength. A lot of these will be reported in KSI, in other words, kilo pounds per square inch. So that's what I've got here. You know, if the A992 is 50 KSI, that's the same as 50,000 PSI. Just good to know our prefixes there, and that kilo means thousand. What we're going to do, and if you're watching the video, you're getting a little life hack here, I'm making your life easier, is we're going to copy these and say these are the same as the compressive values. Because in fact, for most steels, the compressive value is generally considered to be much, much higher than the tensile value. So usually they'll report the tensile and say, well, you're not going to break it by compression. If you break it, it's going to be by tension. So we're just going to copy it. We're going to say, okay, whatever can handle in tension, it can handle that in compression as well. It can probably handle more, but this is a good, safe thing to do. So then what we're going to do is we're going to go back, and I'm going to be doing my Warren Truss, my Truss A, and we're going to look at the research we found in MD solids and find our maximum tensile and compressive loads. So according to what I had before, my maximum tensile load was this 672,000 pounds. So I'm going to copy that down. And let's make that a little bit smaller. There we go. And the maximum compressive load was very similar, so our numbers aren't going to be too crazy different here. But sometimes if you have a different kind of truss, there's going to be a lot more compression or a lot more tension. So it is good to check both. For a Warren truss, they're usually pretty symmetrical. This here, make sure you see this factor of safety. So what factor of safety, by the assignment, we have defined it as 2. So everything's got to handle twice of what it's going to be. So if the theoretical max load that our truss is going to feel is 672,000 pounds, if the factor of safety is 2, it means I've got to design it for twice that. So, in other words, the maximum load it really needs, and I'll do this over, if I do my 672,055 times 2, is really 1,344,000. And I should have given you a better place to write this. I'm going to actually write this here, write this down here. With factor of safety, it needs to be 1,344,110. And very similar for the compressive load, 678,983 times 2. 1,357,966 pounds. So if that's the maximum pounds, right? I'll write that pound. Well, our units really will tell us that for the area, I'm going to do pounds over pounds per square inch. So if I need 1,344,000, yada, 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 first I'll do the structural steel, divided by 50,000, because I'm doing pounds and pounds. I don't want kilopounds right now. So there needs to be a 26.88 square inch area, just to handle all the force. That's the area. Now, talking about IXX, talk about geometry, we'll figure out that later with deflection. But the area, just to handle that load, at least 26.88 for the A992. Let's do, whoa, what menu did I get in? There we go. Let's do similar, but then instead of 50,000, we're doing 36,000, boom, 37.33, and similar, 40,000, 33.61. So this gives us the area that our, presumably it'll probably be an I-beam. That total area to support this truss, if I'm doing, for example, that A992, the total area in there, let's maybe go like this, make it nice and small. That total inner area has to be 26.88 square inches if I'm going with the A992 structural steel. That's what it's telling us. And that is the axial force part of this.